Select the major product of the following series of reactions. So we see that we are given two equivalents of an aldehyde. So we need to be thinking about the chemistry that aldehydes do. You can have nucleophiles attack their carbonyls, and they're also slightly acidic at that alpha carbon. And we can see these first two steps. So we're treating this with aqueous base and water, and following that up with H3O plus and heat. These are aldol condensation conditions. So we are bringing together two of these aldehydes. So that means that we are going to deprotonate a little bit of one. So I'm just going to go ahead and draw the enolate. And this can react with the carbonyl carbon of another equivalent of the same aldehyde. So we can I'm just going to show this first attack, not the whole mechanism, but just so we can see how we are bringing these two pieces together. So we're going to draw first the aldol addition product, and then we'll do the elimination to make it overall the condensation. Okay, so I'm going to draw the attacking aldehyde. So there we have it, and let's number our carbons so we can see. So we have 1, 2, 3, 4 carbon atoms of one, and 1, 2, 3, 4 carbon atoms of the other. So you can see how we're joining these together and make sure we don't lose any carbon atoms along the way. So I'm going to have the attacking enolate. So this is carbon 1, there's carbon 2, 3, and 4. So I'm kind of angling those out of the way so I can show the new bond here. That's our new bond. So this was our attacking enolate, 1, 2, 3, 4. And then we're going to have the 4 carbon atom chain of the aldehyde that was attacked. So 1, 2, 3, 4. And when we do that attack, we're going to push electrons up into the oxygen. So we'd have a negative charge. And then once it gets protonated, we get to this, our aldol addition product. So let's go ahead and number these. So we can clearly see these two 4 carbon atom fragments that came together. And then when we heat this up with aqueous acid, we're going to dehydrate, and we're going to make this new bond into a pi bond. And so it forms there, so it is conjugated with the carbonyl. Okay, so here's where we had that alcohol. So now we have a double bond, and we have our aldehyde. And we still have this 2 carbon atom fragment that came from that original aldehyde. So I'm going to put the numbers back on so we can see. Make sure we haven't lost any carbons. So we still have 4 carbon atoms, and we should still have 4 here as well. So that's our aldol reaction. And then our next 2 steps, we are adding a Grignard. So we're doing a Grignard addition. And so your Grignard is a hard nucleophile. So that means it has a concentrated small charge. So it's a hard nucleophile. So this should add to the carbonyl. So we're going to add a Grignard to that carbonyl. So we can show this attacking the carbonyl. So we're adding one more carbon atom there, so that we will form overall this molecule. So after you've attacked, it's going to become an alcohol, right? Because we're adding in a protonation step, and you've added a methyl group there. Okay, and I showed this protonation with H3O plus. You'd actually have to be pretty careful with that because of the double bond. So it'd be a very weak concentration, or you might even see water or an alcohol as your proton source. So then we want to find that structure here. And here we have it in B. So I'm going to go ahead and number our carbon atoms so we can still see these are the 4 carbon atoms that came from one of those equivalents of the aldehyde. And then here, I'm going to use green. These are the 4 carbon atoms that came from the other equivalent. And then right here off carbon 1, we've added that methyl group from your Grignard reagent. So there it is.